All right, welcome back. This is Unit 1, Day 6. And today is where everything comes together from the last few days. We are going to solve. So we'll be solving exponential and logarithmic equations. So we are putting everything together. We are going to look at our exponential equations, and then we're going to use logs to solve them. We're also going to look at some logarithmic equations and see how we can solve those. So we will start with exponential equations. We'll do those first. We'll do some examples, and then obviously we'll practice in class, and then there's going to be a little bit more that we will add on to our class notes next time. The challenge in teaching you this is that there's a couple different ways you can solve. So I'm going to show you two different methods for solving some of these. Okay, our first example, we're going to start pretty basic. The first type of exponential equation that you could have would be one that would be solve without a calculator. Okay, and it would say something like 8 to the x equals 2 to the 2x plus 1, something like that. All right, and these are both exponentials on both sides, and it says solve without a calculator. So this direction of solving without a calculator is kind of your clue that you should be able to do this just by using your brains. So that is an indication that you need to be able to take this 8, because that's the bigger number, and rewrite it so that it is 2 to a power. So you should be able to rewrite these so that they have matching bases. So you're going to take the 8, rewrite it so that you have 2 to the 3rd power, and then there's still an x on the outside of that. And then over here, we're going to leave that alone because that's already a base 2. So now you have a 2 for a base on the left and 2 for a base on the right. So these are matching bases. So if the bases match and the left side equals the right side, that means that you have to have matching exponents. If this equation is true, the left has to equal the right. So the bases already match. That means your exponents have to be equal as well. So what we're going to do is not cancel anything out, but we're just simply going to ignore the bases. And we're going to say that this exponent on the left has to be equal to this exponent on the right. So our focus is going to be on those exponents. 3 times x, because a power to a power, you multiply the powers. 3 times x has to equal 2x plus 1. Because people ask me all the time, what happened to the 2's? We didn't do anything to the 2's. We're just kind of ignoring them. We're focusing on making the exponents match because the bases already match. So now we are going to subtract 2x. We get x equals 1. And if you check that back into the original, if you substitute the 1 back in up here, 2 times 1 plus 1, we get that exponent's a 3. And if you substitute it back in on the left, 2 to the 3rd equals 8, and 8 to the 1st equals 8. So this is the value for x. It's going to make the left equal the right. All right, and we'll practice that type some more in class. All right, another type would be if you just have one exponential equal to a number. So something like this. it would say solve. I'm bad about writing the directions to the problem. Solve 2 to the x equals 7. All right. So for 2 to the x equals 7, you have 2 different ways that you can solve this problem. So I'm going to show you both because for some people, one method makes more sense than the other. There's actually 3 different ways you can solve, but I don't want to confuse you, so I'm just going to show you 2 of them. One way is if you use the definition of a logarithm and you change this to log form, because remember, the whole point of a logarithm is to help you solve for x in the exponent. So if I want to know what x is, I'm going to change to log form. Hopefully you've thought about that, what that would look like. Remember, the base has to be 2 because the bases have to match. And then the number over here that's by itself, the 7, that's the argument. And then x, the exponent, is what you're solving for. So that's over here by itself. So log base 2 of 7 equals x. You would just take that and type it in your calculator. Now you've got 2 ways to type that in your calculator. If you've got a newer calculator, you go to math, option A that says log base, and you can type that in as log base 2 of 7 and hit enter. If you've got an older calculator, you're going to use the change of base formula that says to type in log of the big font over log of the tiny font, biggie smalls, like we talked about in our last video. Or you just remember that the base goes on the bottom. So you can do either one of these. Either do this one or this one. But type that into the calculator and you get that x equals 2.807. So try that out. Make sure that you get that to work. So that's one way you can solve it. Another way you can solve is if you take your 2 to the x equals 7 and instead of changing to log form, you can treat the fact that exponentials and logs are inverses by kind of using the log as an inverse operation. So what I usually tell my students is, I'll kind of go over here to the side, if you had a problem like x squared equals, 10. If I wanted to get rid of a square, I would use a square root. And then if we were talking to each other face to face, I would ask you, why did you pick a square root? And you would say, Mrs. Fisher, I picked a square root because a square root and a square cancel each other out. And then I would get x equals plus or minus root 10. All right, so you choose that because they're inverse operations of each other. So in our lessons, I've been trying to reinforce the fact that logs and exponentials are inverses of each other. So if I want to get rid of x in the exponent, the way that you would do that is you would use the inverse operation of an exponential, which, friends, is a log. All right, so the inverse of having 2 to the x would be to use log base 2. So you can log base 2 both sides. And so what happens there is you can cancel that out from the left-hand side. And then what you have left then would be x equals log base 2 of 7. And if you notice, that's essentially what we had in method 1. And then you just type it in like we did before, and you get x equals 2.807. And I changed my mind. I'm going to show you the third way. And y'all get to just pick which one you like the best. Method 3 still is using the fact that log and exponentials are inverses of each other. But this one is more focused on using the power property. So this is going to use the power rule that we talked about also last class. You're going to use the power rule, and again, the fact that a log is kind of like an operation. So what I'm going to do is I'm going to log both sides, but this time I'm using the common log. You can use the natural log if you want. So a lot of times I use natural log because I'm lazy, and when I do natural log, it's only 2 letters instead of writing log, which is 3 letters. I'll see what I mean in a minute. I'm going to take the natural log of both sides. So see how when I wrote log on both sides, that's 3 letters on the left and 3 letters that I had to write down on the right. That's 6 whole letters I had to write in. So sometimes when I do this, I just do ln on the left and ln on the right, because that's only 4 letters you have to write on both sides. Y'all think I'm crazy, but that's what I do in real life. So then I'm going to do the power rule, which says if you have an exponent, you can bring that down in front. So then you got x times the log of 2 equals the log of 7. Now this is the method that I used in high school because, for one thing, I could never remember method 1 because I wasn't very good at changing to log form. My teachers never taught me method 2. And we didn't have fancy calculators that would do log base. So we always did method 3 in high school. So this is the one that I use a lot. But now you just get x by itself. And if you notice from this form, this looks a lot like the change of base formula that we wrote down in method 1. So you can just type that in your calculator. You're still going to get 2.807. There are some problems where you have to do method 3. So anyway, this is kind of, again, like if you had x squared equals 10 and you have to square root both sides. So I kind of like method 3. 2 or 3. I kind of like those. I don't often use method 1, but some people really like that one. But y'all can choose. Free choice. All right, let's look at another example. I know it's confusing sometimes when we give you lots of different choices for methods. But if you have questions on how to do any of that, obviously, it's why we give you a preview now, and then we have an opportunity to go over all of this stuff in class so you can get help on it. Again, we did this in Math 3, so hopefully this is just a refresher. So let's look at this example. 3 to the x minus 5 equals 10. Add 5 to both sides. We're trying to solve for x, so you got to get rid of the numbers. So add 5. You get 3 to the x equals 15. So from here, you can do any of the 3 methods that you want. And like I said, I prefer to use the log like it's an operation. So I'd like to take the log of both sides personally. Y'all can do whatever you want. And I already mentioned I like to do ln because it's faster to write. So it really doesn't matter. And then I use the power rule and I bring x down in front. So x ln 3 equals ln 15. And then you can divide both sides by ln 3. So x equals ln 15 divided by ln 3. So that's how I like to do it. If you don't like that method, that's perfectly fine. A lot of my students end up going from this step. They like to do the definition of a logarithm. So they change this to log form. So from this step, they like to do x equals log base 3 of 15. And then use the log base. Because if you have a calculator that does that for you, log base 3 of 15, then this form is really easy. Because now you just type it in, x equals 2.465. So now that calculators do that, this is obviously a lot shorter than what I just did. So y'all can pick whichever one you want. All right. So again, I kind of feel like for your notes, so this one uses definition of logarithm. This one is what I would call taking the log or ln of both sides. All right. That's kind of what the two methods are there that I just showed. If you want to see the other one in class, I'll be happy to show you. All right. Let's look at one that's a little more complicated. So example 3. This one you have to use the method where you take the log of both sides. You'll see why in a second. All right, so for this one, I'm gonna move my equal sign over a little bit. All right, for this one, when you have exponents on both of your bases, the first thing you want to look for is whether or not you can make the bases match. Kind of like an example, the very first example, I guess I didn't number it, but this very first example at the top, see if you can make the bases match each other. And we cannot make a 4 and a 3 match each other. We cannot rewrite those as powers of each other. So we cannot do anything other than use logarithms. So because there's exponents now on both sides, the only method we can use to solve is to take the log of both sides, which is kind of why I use that one method all the time, because it works for all of the problems. But again, it's not the quickest method for all of them, but it does work for all of them. So I use the one where you ln both sides or log. I'm just lazy. And then it's the power rule. So you're bringing this power down in front. You're bringing this power down in front. And so you end up with 2x minus 1 times ln of 4 equals x plus 5 times ln of 3. And then you have a mess on your hands, because then you have to get x by itself. And to get x by itself, you have to get all of the x's on one side of the equation, and anything without an x has to go on the other side. So to do that, we need to take our ln stuff and distribute. And like I said, it's a mess. But y'all are smart, you can handle it. So ln 4 is just a crazy decimal. If you type that into the calculator, it's a decimal. So you would treat it just like you would if that was like a 5. If I had a 5 there, I would just distribute and multiply it times the 2x and multiply it times the negative 1. So that's what you're going to do. It's just going to look kind of gross. So I would take, like I said, if it was a 5, and I have it times 2x, I'd multiply the 5 and the 2 together. But this is an ln 4. So what I'm going to have is a 2 times ln 4, and then I've got this x hanging out there. And then ln 4 times a negative 1 is a minus ln 4. So that's what that looks like once you distribute it. It's gross. And then on the right, we're going to do the same thing. We're going to get ln of 3 times the x that's there. plus 5 times, whoa, I think it thought I wanted to make a line, times the ln of 3. Now, our terms that have an x are this guy here and this guy here. We need to put them on the same side, and then we need to put these guys on the same side, the ones that don't have x's. So that's what I'm going to do next. I'm going to put the x's on the left. So I'm going to have 2 ln 4 times x, and then minus ln 3 times x. On the right, I'm going to add the ln 4. So we're going to have 5 ln 3 plus ln 4. Super gross. All right, now we need to get x by itself. So that means, if you see here on the left, we have this x right here and this x right here. So since these two terms both have an x in them, we can factor it out. So we are going to factor out the x, leaving you with 2 ln 4 minus ln 3. The last step in getting x by itself then would be to take everything in the parentheses and divide it over to the other side, because right now it's being multiplied by x. So we're going to divide it over to the other side. I warned you it was a mess. Okay, nothing there cancels out. That's what you have. If it asks you to leave your answer exact, that is an exact answer. If you are told that you can leave your answer as a decimal, you would just type that into your calculator. I don't know what that is off the top of my head, but we will definitely practice that some more in class. All right, let's look at solving log equations. Okay. All right, so log equations are equations that start off with a log in them, but we're still trying to solve for x. So, for example, if we have one like log base 2 of x equals 3, and we're trying to figure out what x is. This is another instance where you have a couple different ways that you can solve. So one way you can solve this is using the definition of a logarithm, which means change from log form to exponent form. So this is definition of a log. So you would change this to exponent form. So that means you would say 2 raised to the third power equals x. So 2 raised to the third power equals x. So that means x has to equal 8. So that's one way. Pretty easy. But you have to remember that that's what the problem wants you to do. The other way you can solve this problem is using inverses. Using inverses, let me rewrite the problem. Using inverses, you were basically using one of the basic properties of logs. And this one's a little bit weird, but people that understand it really like this one. But what you do is you make both of the left and the right here, you make these exponents of a large base. So you're going to make these exponents. And the base that you choose is going to be 2, because this problem is log base 2. So what I'm going to do is I'm going to put a giant 2 here on both sides. Because remember, whatever you do to the left, you can do to the right. And again, this is the method that I chose to do in high school because I was not very good at the definition of the logarithm for some reason. I don't know. I was just terrible at it. So that method 2 is what I chose to do, even though it's really weird. But you make the stuff in blue exponents, and so you choose this large 2. And the reason I chose base 2 is because base 2 of the exponent and then having base 2 for the log, they're going to be inverses of each other and cancel each other out. So that's going to cancel out, leaving you with x equals 2 to the third, which is basically the same problem we wrote down in method 1. So you get x equals 8. So it's kind of a weird method, but it gets you the same answer. So that was kind of a way you could do the problem without having the definition of a log completely committed to memory. I had ways of getting around memorizing things sometimes. All right, so log problems can be a little bit more complicated than what we have here, but the method's going to be the same. If you have something like log base 2 of x plus 1 minus 2 equals 5. It's the same idea. Your argument is where the unknown is, but you want to get that by itself first. So you need to add 2 to both sides. So say log base 2 of x plus 1 equals 7. And then you're going to solve that. So you can use either of the methods that we just talked about in the first example. So you can either use definition of the log and say 2 raised to the 7th equals the argument, or you can do make 2 your base on both sides. So either one. But either way, you'll get 2 to the 7th equals x plus 1. 2 to the 7th is 128. Subtract 1 from both sides, you get 127 equals x. All right, the last type that we're going to go over, and then we've got, again, more to talk about in class, of course. We are going to look at log of x plus log of x minus 1 equals log of 4x. So this one looks way more complicated, obviously. But what you need to do here when you have multiple logs in one problem is you need to take these two right here and you need to combine them into one log. So the reason that we talked about properties of logs the other day was because of a problem like this. If you have more than one on one side, your first step is to combine. So when you have an addition, we combine them using the product rule. So that becomes one log, and then we do the product of x times x minus 1. So you're going to do x times x minus 1. All right, so that's really log of x squared minus x. Okay. And these are common logs, so if you need the base is 10. Keep that in mind. The reason I'm saying that is because in this problem, it's a little bit different than the other two examples because we have a log on both sides here. These other examples didn't have a log on both sides. So this is a different type of example because if you have a log on the left and a log on the right, then the way you're going to solve this is if the left does indeed equal the right, then the only thing you need to focus on is making the arguments equal. And here's where that method 2 is really helpful. Okay, if you know there's an understood base 10 here, using that method where you make these both exponents of a big 10, what's going to happen to your logs? They're just going to cancel out. So your focus here is really on just making the arguments equal each other. So x squared minus x has to equal 4x. Okay, so you can either just think to yourself, I just need to make the arguments equal, or you can use this big 10 and just focus on, again, the arguments have to be equal. So we've got a quadratic, we need to solve, subtract 4x from both sides. Okay, you're going to get x squared minus 5x equals 0. Factor out the x. All right, so x equals 0 or x equals 5. All right, if you go back and check the original problem, x equaling 0 is a big no-no in the original. You cannot take the log of 0 up in here. That was one of the things that we wrote down when we were talking about logs at the very beginning. That argument cannot equal 0, so we toss him out. Okay, 5 does not make any of those arguments in the original equal 0, so our only answer is that x equals 5. All right, that's it for today. We will practice some more stuff tomorrow, and we'll also talk about Newton's law of cooling. Have a lovely day, and we'll see you later.